unchanged galaxy discovered in space. Italian astronomers discovered ancient fossil galaxy located nearly 3 billion light years away. A team of Italian astronomers has made a groundbreaking discovery of a rare and ancient fossil galaxy located approximately 3 billion light years from Earth. This finding represents the most distant example of such a galaxy ever observed beyond our local cosmic neighborhood. Okay, now let's unpack the layers of this story in our deep dive on the AI podcast.
Let's unpack this. Imagine looking through a cosmic time capsule, not just a few years back, but billions. Today, we're embarking on, well, an incredible journey to the universe's earliest moments, setting the stage for a truly cosmic adventure.
Yeah, and what's fascinating here is that this journey isn't just about incredible distance.
Right.
It's really about understanding deep cosmic history.
Right.
We're talking about peering back to a time when the universe was, truly in its formative years. And it's all thanks to an exceptionally rare and special object.
And for this deep dive, our mission is to understand a groundbreaking discovery. KiDS J0842+0059. This is apparently the most distant known fossil galaxy recently uncovered by Italian astronomers.
Okay.
So we're going to explore what a fossil galaxy actually is, why this particular one is so incredibly special, and crucially, what profound insights it offers us about the very early universe. So this amazing find was made by a team of Italian astronomers. They're from the Italian National Institute for Astrophysics, INAF. They use an instrument called the Large Binocular Telescope, which is perched atop Mount Graham in Arizona. Now, this isn't just any telescope, right? It's powerful enough to capture light that has traveled for billions of years to reach us, letting us peer deep into the cosmos.
That's absolutely the key. This particular fossil galaxy, KiDS J0842+0059, it's located approximately 3 billion light years from Earth.
3 billion.
Yeah, and to truly grasp that, you need to consider this. The light we are currently seeing from this galaxy, it began its journey 3 billion years ago.
Wow.
It's a pristine glimpse into the universe exactly as it appeared in its very formative years. A true cosmic snapshot, you could say.
Given that immense distance, seeing light from 3 billion years ago, just detecting this galaxy must have been an incredible challenge. How difficult is it to spot something like this?
Oh, it's an immense feat. The lead researcher, Crescenzo Tortora, he's explained just how challenging it is. He noted that the light from these incredibly distant galaxies takes, vast periods to become visible. And even then, a multitude of cosmic factors can distort or even completely erase that signal before we can ever detect it. It truly is like finding a single ancient needle in a cosmic haystack. It's that tough.
Okay, here's where it gets really interesting. We keep calling it a fossil galaxy. It sounds almost mythical. So what exactly is a fossil galaxy, and why is this classification so rare?
Well, they're often called relic galaxies, too, and the name gives you a pretty good clue. These systems are incredibly rare, dense, and compact. What makes them unique is that they've remained largely unchanged for billions of years.
Billions, okay.
Think of them as cosmic time capsules that somehow just avoided the usual wear and tear of the universe.
That's a fascinating concept. So if they remain unchanged, how do they even form in the first place, if not through the typical, galactic evolution stuff?
Well, they formed very rapidly. Right back in the early universe, they underwent this powerful initial burst of star formation. They essentially accumulated the vast majority of their mass in a really short period. Chiara Bignello, she's a study co-author, she specifies that for a galaxy to qualify as a fossil, it must have formed at least 75% of its mass in its very first phase of life.
75% right at the start.
Pretty much, yeah. A huge chunk right away.
So it's really about the absence of those common galactic mergers that preserves their ancient state. Does their formation imply they somehow avoided the more chaotic phases of galactic life that most galaxies experience?
Absolutely. That's the core idea. Unlike most galaxies that undergo dramatic transformations through continuous interactions and mergers.
Which is most of them, right?
Yeah, the vast majority. But these relic galaxies, just by chance, as Crescenzo Tortora put it, did not merge with any other galaxy, remaining more or less intact through time.
Just pure luck, maybe.
Could be part of it. They are incredibly rare because, the probability of merging naturally increases over cosmic time. So to remain isolated and undisturbed for billions of years is quite extraordinary.
So they just exist in isolation, almost frozen in time. What do they actually look like? Visually or in terms of their composition?
They preserve their ancient forms. They're extremely dense, packing billions of stars into relatively small volumes.
Billions in a small space.
Exactly. And they show very little, if any, signs of new star formation. As Chiara Spiniello observes, they're essentially doing nothing.
Oh.
They are the fossil records of the very ancient universe. They formed when the universe was really, really young, and then, for reasons we don't yet fully understand, simply remained untouched by the usual cosmic churn.
Okay, that leads to the big question, doesn't it? Why? Why did these specific galaxies avoid mergers when nearly everything else in the universe seems to be colliding and evolving all the time? What's the leading hypothesis? Is there one? What could explain why these unique galaxies managed to avoid all those interactions?
That really is the significant unanswered question. Chiara Spiniello states it pretty directly. For some reasons that we honestly don't understand yet, they did not interact.
So it's still a major mystery.
It's one of the biggest mysteries about them, yeah. However, there is a prominent theory currently being explored.
Okay, and what does that theory suggest?
Well, the theory posits that supermassive black holes, lurking at their centers, might have played a crucial role.
Ah, black holes again?
Right. They seem to be involved in everything. The idea is these black holes could have generated intense galactic winds.
Winds, like blowing stuff away.
Exactly. These winds would have been powerful enough to push away any incoming material, gas, dust, maybe even smaller galaxies. This would prevent further star formation and interaction.
So like an invisible shield?
In essence, yeah, creating an invisible shield around the galaxy, keeping it isolated. It's a compelling idea, but still needs more evidence.
Okay, so considering its immense distance, 3 billion light years, and this pristine, unchanged condition, how does KiDS J0842+0059 become such a uniquely vital cosmic time capsule for astronomers? What can we really learn from it?
It's vital precisely because we're seeing this galaxy as it was 3 billion years ago, completely undisturbed. This provides astronomers with a pristine, direct glimpse into the galaxy, exactly as it came into existence. It's like opening a book to chapter 1 and finding it perfectly preserved.
Okay, I see.
This direct observation of an ancient undisturbed system, it offers key insights into the early stages of galactic evolution. If we connect this to the bigger picture, it allows us to test fundamental theories of how galaxies first formed their mass and, importantly, why some stopped evolving so early on.
So it's like a control group, almost.
In a way, yes. It's a pristine natural experiment. It shows us a path of galactic evolution that was largely undisturbed, which is incredibly rare and valuable for comparison.
And there you have it. I mean, the incredible story of KiDS J0842+0059. We've sort of explored what a fossil galaxy is, how rare and unique this specific one is, and what it's already teaching us about the very early universe. Discoveries like this aren't just about finding new objects out there, are they? They're really about understanding our cosmic origins and the vast, evolving story of everything around us.
Absolutely. Studying these rare, undisturbed fossil galaxies helps us piece together the puzzle of universal evolution in a really unique way. They provide a baseline, of what an untouched galaxy looks like. Chiara Spiniello herself expressed hope that KiDS J0842+0059 will remain forever undisturbed. It's truly a fixed snapshot in time that tells us so much.
So as you go about your day, maybe take a moment to consider the sheer vastness of cosmic time. Think about how some galaxies, like KiDS J0842+0059, have remained virtually untouched for billions of years. Why did they avoid that cosmic dance of mergers and transformations that defines so many other galaxies? What more could these ancient galactic relics teach us about the universe's grand evolving story? And what profound secrets are still waiting to be revealed within their quiet...
Could supermassive black holes be responsible for preserving fossil galaxies by halting star formations and interactions? Don't forget to comment it. Thanks.